Good afternoon, everyone. My name is Kendra Indriwayoningsih. I belong to Department of Environmental Science and Technology, Kyoto University. Today, I would like to deliver my presentation about rice's biochar application as a mitigation strategy for nitrous oxide and methane emission in sandy paddy soil. As we know, rice has become the staple crop globally, and greater food demand on rice can cause several environmental problems. For example, produce more rices and increase GHG emission. In this study, we use sandy soil because it will emit higher nitrous oxide emission due to a lower percentage of water-filled pore space, promoting nitrification rate. And sandy soil also increases the diffusivity of methane to the atmosphere, and it has lower amount of free manganese dioxide and ferric oxide, thus reducing the sequence of electrons after use in methane production. So biochar is carbon-rich porous material produced under limited oxygen status, and the characteristics are determined by the feedstock and pyrolysis condition. So the increase of pyrolytic temperature leads to the augmentation of surface area and micropores in biochar, and it may have potential to decrease both methane and nitrous oxide emission. So converting rices to biochar might be one viable option for reducing agricultural waste, decreasing GHG emission without declining the yield. Mid-season drainage is the removal of surface water from the rice crop at mid to late tillering for 10 until 14 days. So the previous studies found that mid-season drainage is widely used in Japan to reduce ineffective tillers, and it also decreased the average methane by enhancing oxygen availability in rhizosphere. However, it has side effects due to trade-off relationship between methane and nitrous oxide. So it is necessary to find the best combination of agricultural practices to decrease both nitrous oxide and methane gas emission, as well as increase the crop yield simultaneously. So the objectives of these studies were to determine the response of nitrous oxide and methane emission to rice's biochar and different irrigation type, and also to assess the impacts of rice's biochar and irrigation type on plant growth indicator and crop productivity. So the pot experiment was conducted in the Greenhouse Graduate School of Agriculture, Kyoto University, and this study used randomized block design with 3 treatments. The first one is pyrolytic temperature, consisted of 300, 450, and 600 degrees Celsius, and then biochar application rate, 20 and 200 kg per hectare, and water management type, mid-season drainage, and continuous flooding condition. And these treatments were replicated 3 times. This study also used sandy loam soil with slightly acid pH, and then TCT and NCN ratio were relatively low. The fertilizer used were nitrogen 100 kg per hectare, phosphorus and potassium 90 kg per hectare for each. These are the agricultural events during my study, started from basal fertilizer and biochar application until the rice harvesting and soil sampling. For the methodology, started from biochar production using laboratory scale production, and then proximate analysis was conducted to measure moisture, volatile matter, ash, fixed carbon content, and carbon loss during pyrolysis. And then elemental analysis was used to measure the chemical properties of biochar. For the gas sampling, we measure methane, nitrous oxide, and carbon dioxide gases using closed chamber method. And the gases were taken in triplicate 0, 15, and 30 minutes in the morning and in the evening. Soil surface water temperature, pH, and soil redox potential were also measured. And we'll also take the liquid sample, so samples and plant sample, and then the inorganic nitrogen, carbon, and nitrogen content of the soil, and also the weekly plant growth indicator, the yield, and carbon and nitrogen content of rice straw and rice grain were also measured. We are moving to result and discussion part. So the increasing of pyrolytic temperature lead to the decrease of biochar yield. It's because more compound converted into other products such as gases. And the increase of temperature also increased the ash content because the residual concentration of inorganic compounds. It also influenced calcium and magnesium content of biochar due to the separation of alkali salt from organic matter, and indirectly increased the biochar pH. Silica was also augmented because the increased temperature changed the form of original silica to be amorphous. For the gas parameters, so the first one is methane emission. The methane trend during the rice cultivation started from the initial stage. It was close to zero because this study only used inorganic fertilizer and biochar application without adding any organic matter. And then the increase of vegetative stage because more developed parenchyma tissue will emit more methane to the atmosphere. And then the decreasing trend during the last stage of grain maturity, it's because the reduced available assimilate for methane production. Methane drainage also promoted cell redox potential values by enhancing gas diffusion and oxygen availability, thus reducing methanogen but increasing methanotropes population. And it became the responsible factor for effective reduction of cumulative methane emission. During mid-season drainage also decreased nitrate leaching due to a smaller amount of leaching water from paddy field. And the study also found a positive correlation because the methanotrophic bacteria that has a relatively high nitrogen requirement for assimilating carbon. So the increase of nitrate leaching in continuous flooding condition might decrease nitrogen availability for methanotropes activity in methane consumption. So generally, biochar significantly influence soil pH. In a higher soil pH, resulted in a higher cumulative nitrous oxide emission and was found in this study. It's because the soil pH augmentation might increase nitrification rate. And higher cumulative nitrous oxide emission also found in a continuous flooding condition. The possible reason is anaerobic condition combined with more nitrogen substrate will increase the nitrification rate. For the carbon dioxide emissions, so for the daytime flux were mostly negative. It's because the prevalent uptake of carbon dioxide for photosynthesis, and for the nighttime flux, because the absence of photosynthesis, so the fluxes were positive, and the decreased trend during the late stage of grain maturity, caused by the maturation of some leaves during the mature stage of plants. For the crop productivity, so the increased yield in a higher temperature of pyrotic temperature, because the greater biochar surface area might enhance the ability to bind inorganic compounds for plant growth. And then the smaller dose of biochar increase the yield because the excessive amount of biochar may inhibit plant growth due to some chemical compounds produced during the combustion process. And then mid-season drainage increased the grain yield and total above ground biomass by enhancing the aeration of roots and reduce ineffective tillers. For the conclusion part, so mid-season drainage can decrease both methane and nitrous oxide emission. And then for the grain yield, higher barotic temperature, smaller dose of biochar, and mid-season drainage resulted in a higher grain yield. And for the plant growth indicator, mid-season drainage had a better result. So it is recommended to apply 20 kg per hectare of 600 degrees Celsius biochar combined with mid-season drainage to decrease methane and nitrous oxide emission while maintaining the highest crop yield in sandy paddy soil. Over the acknowledgement, so this work was supported by the Laboratory of Soil Science, Department of Environmental Science and Technology, Graduate School of Agriculture, Kyoto University, and also Indonesia Endowment Fund for Education, Ministry of Finance, Indonesia. That's all from me. Thank you for listening.